Hello, I'm Naomi Oreskes. I'm a professor of history here at UCSD and director of the Science Studies program. Our guest today is Chris Mooney, who's the author of the New York Times best-selling book, The Republican War on Science. Welcome, Chris.
Thanks. It's good to be here.
So tell us a bit about the book. It's a pretty provocative title. What motivated you to write the book? And explain the argument for us.
Well, we've seen a pretty widespread problem in terms of political interference with science in the Bush administration, also, frankly, in Congress and even at the state level where all the evolution battles are playing out. So there seems to be a really systematic problem here. And what I did was try to look at all the issues where there are political science fights like global climate change, reproductive health, evolution, stem cells, and so forth, and see if there was any underlying theme to what was going on here. And sure enough, I found that generally most of these problems fit into two categories. Either science is being distorted because there's some economic interest at stake, or else there's some moral, ideological, religious interest at stake. And these are the two constituencies of the Republican Party: industry and religious conservatives. So hence, I think that's what's driving a lot of what's going on.
Okay, tell us a little bit about the reaction you've gotten to the book.
Well, I mean, conservatives have not been always, that friendly, although there have been some, very intellectually serious but also critical responses. And there's a couple on the left, sort of in the sort of science studies field that have taken me to task a little bit. But generally, when I go around speaking about this, scientists are very attentive, and at the end they always say, well, what can I do about this problem? They're really concerned.
So the book deals with a long list of ills, like you said, global warming, ozone, creationism, stem cell research. Which of these do you think is most important for us, as for the public to understand? Which of these issues concerns you most deeply?
Well, actually, most deeply I am concerned with the meta issue of making sure that science translates into the best decisions that we can. But I think, in terms of what affects us most, it's hard not to pick global climate change. The whole world is at stake in that one.
Let me play the devil's advocate with you a little bit then, and raise some historical questions. So the historian Dan Kevles, who very well-known, prominent historian, reviewed your book, An American Scientist. And one of the things he said, putting the book in context, he said, well, politicians have often rejected the advice of their scientific advisors. And the most famous example that I think a lot of historians thought of when they read your book was the debate over the hydrogen bomb back in the late 1940s and early 50s. And when scientists realized that a hydrogen bomb was really technically possible, there were many discussions among scientists. And leading scientists, world-famous people like Robert Oppenheimer and Hans Bethe, advised Harry Truman not to build the hydrogen bomb. And they said, look, if you do this, there will be an arms race, and there'll be no end to it. And you'll build a huge stockpile of weapons that no one in their right mind would ever want to use. But Harry Truman rejected that advice, famously. And there's a famous story where a reporter, a journalist, asked Harry Truman, said, President Truman, does this mean that the arms race is on? And Truman said, yes. So eyes wide open, wow. He rejected the advice of his own scientific advisors. So I guess Kevles' argument is, or I guess my question to you is, how is this different?
Well, it is actually different in several ways. First, I mean, since time immemorial, as long as there was information, I think politicians would probably be willing to twist it in order to advance a particular goal. And you could look at international examples where politics has interfered with science, like Lysenkoism in the Soviet Union as well. It's not like this kind of thing hasn't happened before. And if you go back in U.S. history, you're definitely going to find many cases. The first point would be, will you find such a systematic government-wide problem as you're finding right now, or will you find a couple of anecdotes? And the other thing that actually, from that very review that he points out, is that there were a lot of politics and science fights, interactions over military policy, but now it's gotten into social issues, it's gotten into environmental and regulatory policy, and so it's become much more sweeping. And the last point I would say is that actually politicians do have a right to reject the advice of their advisors. We may not agree with it, and certainly in this case, unfortunate that it happened, but that's different from twisting the information and misleading the public about the content of the scientific advice, which it sounds like, although I'm not a historian, may not have happened in this particular case. So again, what we're seeing now is twisting, misinformation, disinformation.
Yes, okay, well, so that's an important distinction. That's interesting. A second example that's often cited has to do with well, Louis Branscombe wrote an interesting article about this that was published in Issues in Science and Technology some months ago. So he also gave some examples, and a famous one that all historians and a lot of journalists know about too is when President Nixon sacked the President's Science Advisory Committee over advice that he didn't like on the question of building a supersonic transport. So again, would you say that that also fits in the category of simply rejecting advice as opposed to distorting it?
Oh no, I think that that's a very problematic case study, and it reminds me of the Gingrich Republicans sacking the Office of Technology Assessment in 1995. So both the presidential science advice and the congressional science advice were sacked at various times. And no, I definitely strongly in favor of having a strong scientific advisory apparatus. If you've gotten to the point where you need to kill the messenger, then there's something wrong. But again, you know, I think that there were some bad things with the Nixon administration, but again, I would argue that the situation is not so systematically bad. And in fact, Nixon's EPA advisor, Russell Train, is one of my sort of sources, one of the guys, a Republican himself, who has decided that he has to denounce the Bush administration because the kind of science games that he's seeing now, he says never happened at EPA during his time. No one would have interfered with the content of an EPA scientific report on climate change, which is one of the case studies from the Bush administration.
Well, that's interesting, yeah. So you mentioned the science studies and that you have received some criticism from what you might consider to be the left of the political spectrum, not just the right. And one of those criticisms was University professor Dan Sarowitz, who teaches at Arizona State University. So he attacked you pretty savagely in issues, also in issues in science and technology, and he accused you essentially of being naive and of holding on to a view of science that's untenable, namely that you buy in, he would say, that you buy into the myth of pure science, that we all know that that's just not true, that science is part of culture, it's part of history, it's part of politics, science has always had a political dimension, and moreover, he would argue it's people like me, historians of science, sociology of science, people like what we do here in our science studies program here at UCSD, people like us who have in fact proven that. So therefore your book, your whole criticism, he would say, is sort of misguided. So how do you respond to that?
Sure. Well, I think that's a stick figure version of my argument, and it's easy to knock down, but actually there are passages in the book that I could quote you where I talk about how scientists themselves have various motives, not only for choosing what research to conduct, but the scientific community generally, there's, you know, infighting. If you send a certain person a paper to review from another person, you can already predict what the review is going to be, no matter what the paper says. Because
not always, but
well,
sometimes.
You know,
right.
In some cases, people really don't like each other. All these science is suffused with these human elements. But does that mean that science doesn't matter? I don't think that anyone would say that. Does that mean that science is not relevant to policy? I don't think anyone would say that. And I make these points about science being a human endeavor, flawed though it is, but we nevertheless still need it at the outset. And then I go on to say it's because we still need it that we should be very concerned about the attacks on science. So it's not of something that I grant you, I don't spend a long chapter discussing all of the sociology of science and history of science and what those valuable fields have established. But it's because that's not really the goal of the book, but I'm perfectly aware of it.
Sure,
Yeah.
sure, that makes sense. So,
Okay.
so would you distinguish then between, I mean, politics with a big P, Washington
Yeah.
politics, versus politics with a small p internal? Is that the distinction?
Well, yeah, I mean, there's all sorts of human factors. It's not just politics, it's, you know, personal ideology, dislike of individuals. All of these things are feeding into the scientific process. But nevertheless, we want to set up the game of science and of science advice so that the best information comes out or the best information gets to policymakers. And I think that there are only very few rather radical people who would actually say that science is completely socially constructed and therefore, you know, it's just as good as any other opinion. I don't think that we're really at that extreme for the most part. I think that now is a time when increasingly scientific information is relevant to a vast array of policy issues. It seems to be more and more. You know, how do you deal with a bioterror attack? What level of hurricane protections do you need to protect the city for 1,000 years? You have to have good science in order to answer these policy questions. That's always going to be true. So I think we can get these distinctions out of the way and we can still go on to make my argument.
Right, okay.
Okay.
So,
Yeah.
so let's follow up on that a little more. So you mentioned social constructionism. So that's the view that science is a social activity, and therefore the social activities involved in science are engaged in constructing the knowledge that's produced. And there's different versions of that way of thinking, and as you say, there's sort of extreme versions which would be to say that it's purely socially constructed and it's just about what people think, in which case science perhaps wouldn't be considered different from religion, voodoo, other forms of belief systems. Or there's sort of more modest versions of it, that we need to understand the social dynamics in order to understand the knowledge production system. But so one of the strong advocates of somewhere between the most extreme and the more moderate view would be Sheila Jasanoff, who's a very well-known scholar of the interaction between science and politics. So one of the things that she would say is that because science is dependent on its social context, that in different situations, the science will be different, and that it's not realistic to think that the science that's done in an academic institution, like here at UCSD, would be the same as the science that's done in a government agency, like the Fish and Wildlife Service, and that you have to expect that there's going to be differences, and that the politics of what goes on, say, in a place like Fish and Wildlife, would be more obvious.
Yeah.
So how do you respond to that?
Well, I think that I actually cite her a couple of times in the book making this argument, this distinction between academic science and science that's conducted for policy making, for decision making. I think that it's a very important distinction, and my argument would be that Republicans now are ignoring the distinction, and that's one of the problems, is that they're demanding a high degree of certainty in some of this, in Fish and Wildlife Service research, or more generally when they try to impose peer review upon science for a regulatory purpose. They're imposing an artificial and unreasonably high demand for scientific certainty upon science that cannot meet this demand, and the reason that they're doing that is because they're trying to gum up the works and slow down the whole process. And this is another kind of misuse of science that I announced. So this is actually kind of a good rebuttal to Sarowitz, in that I'm actually using Sheila Jasanoff's argument in order to explain why science is being interfered with.
But don't you think that science at Fish and Wildlife should have to be subject to peer review?
Well, sometimes it's not plausible to actually peer review. You've got fisheries biologists or wildlife biologists. They're some of the best people in their field when it comes to knowing about a particular species. There aren't many people who can peer review that to begin with, because not many experts about this particular rare species. The information itself is not very good. There are only a couple of these critters in the wild. We rarely observe them at all. You might not have enough data to really construct a good study. You have to use what data you have, some modeling, etc., cobble it all together and make a quick decision about whether building this dam or such, something like that is going to endanger the species. It's not always perfectly objectively quantifiable. There's, expert judgment that has to go into the process. It's science being used for a different purpose. And that's what I think is often being misunderstood, sometimes perhaps willfully, by some of the Republicans in Congress. One thing they try to do on endangered species is they've tried to pass laws to up the burden of proof before these scientists can actually recommend that a particular project should not go forward. Well, what does that do? It basically ties the hands of the scientists, and it might be that, before they have enough evidence, the species is gone. Mm.
You mentioned about the public and how many of these issues do affect us. So one issue that many people in this community are concerned about is stem cell research. And as you know, the state of California has passed a historically unprecedented bond to support stem cell research here in the state of California and to move forward independent of what the federal government does or does not do. And UCSD is poised to play a very, very major role in that initiative. So this is of great concern to this community. But there are people who have quite serious moral reservations about the idea of what I think to try to be as fair as possible to their position, what they view as human experimentation. So don't those concern you at all?
Well, I don't share their particular moral concerns, but I think I can say that I respectfully disagree with their moral concerns, and that's what sort of happens in a diverse society, and that's politics is the process that adjudicates between these concerns. But what troubles me is not the existence of moral concerns about the particular form of research that I don't share as strongly, but rather the fact that it's pretty clear that people on that side who think it's immoral have also been willing to misuse science in order to defend that stance. And one of the ways in which they misuse science on the stem cell issue is they put out a position that stem cell researchers do not agree with, which is that adult stem cell research using regenerative body cells in the bone marrow and the liver and other places, that this is a rival or even superior to embryonic work. And if you go and talk to a scientist who's doing this research, they'll say, we want to pursue both avenues. Why would we shut one down before we know enough about it? But that's their argument. And it's a twisting science kind of thing that I'm trying to critique. And so that's where I would say we can respect the moral concerns, but we shouldn't misuse or distort the information.
Mm-hmm. Well, that seems fair enough. But what about safeguards? I mean, I know you don't specifically talk about this in the book, but I mean, do you feel that there are some safeguards that ought to be put in place? And if so, who should make the decisions about the safeguards? Do you think the scientists, I guess to put it a little harshly, do you think the scientists can be trusted, or do you think, or isn't that a bit like letting the foxes guard the hen house?
I think we obviously need to bring bioethicists into that process. I think the National Academies did a report about what the ethical rules should be for conducting stem cell research and therapeutic or human cloning research. One thing they said is that women should never be paid for their eggs and all of these kinds of moral considerations. I think that there's definitely a place for that. All I'm saying is that we shouldn't distort the information to get to a particular moral endpoint that we've predetermined that we want to get to.
let me ask you again, to return to the title of your book, The Republican War on Science. So some people have said, isn't that a bit unfair? I mean, to lay all the blame for all of these problems on Republicans. And I mean, surely, what about the Democrats? It's not as if they've done anything about global warming, for example. Or what about scientists? I mean, haven't they, don't they have some role to play? Have they brought any of this on themselves in any way?
Well, actually, I think that the Democrats have, on occasion, first of all, not all Republicans are equally guilty. That's the first point we should get out. Governor Schwarzenegger, for example, is not a global warming denier. And so I'm critiquing the mainstream of the party today and its leadership and the way the party acts as an institution. And I think that my critique is pretty on point when you look at how the mainline Republican Party is run. There are dissenters in any party. They're the moderates, and generally they're not as bad on these matters. Democrats have clearly misused science in the past. And there was just an interesting example where Barack Obama was giving a speech about global warming. It was a very good speech, but he threw in tornadoes. And there's not, he was talking about hurricanes, then he jumps to tornadoes. There's actually some evidence that global warming may be intensifying hurricanes, but on the tornado thing, I don't think anyone's seriously talking about that. Why is he throwing that in there? Maybe he's just misinformed, I don't know, but that's, it shouldn't be done.
Yeah.
In the book I talk about John Edwards, a more disturbing case where he's on the political campaign trail and he's called upon to talk about stem cells, and he says, if you vote for Kerry and I, people like Christopher Reeve will get up out of their wheelchairs and walk again,
right.
Which is really, really an alarming, outlandish statement. It's exaggerating the state of the science and making a promise about an uncertain field of research that you can't make. We can't say what cures to what diseases are going to emerge on what time. So there's a politician, a Democratic politician, misusing science. Not that it doesn't happen, but of course Democrats, A, aren't running the government, and B, they aren't doing it as systematically, I would argue.
Yeah, well, and of course people get confused a lot. I one time heard a speech where a very prominent politician talked about global warming caused by the ozone hole.
Right.
And of course, if you've studied the question, you know that those are actually two different issues, but
it's important to get it right.
It would be good if they got it right.
Yeah, I'm not saying that Barack Obama did this intentionally.
No, he probably got confused. Although there is actually some research about the possibility of changes in tornado patterns as well, so it's possible someone may have mentioned that to him. Tornadoes are very, very tricky.
Yeah, exactly.
So let's go back and talk in a little bit more detail. You begin the book with a discussion of the stem cell question and Bush's speech on the issue. Tell us a little more about that.
Well, this was the president's, one of his first major addresses to the nation, and he stood up there and he had to say all this complicated science stuff. What was unfortunate was that he got a crucial piece of the science wrong, and he got it wrong in a way that he really shouldn't have, because if he'd gotten good advice, this kind of error would have been caught, and the error really mattered. And it was the claim that there were more than 60 embryonic stem cell lines available at the present moment, so his policy was going to enable federally funded research on these 60 lines. And that sounded like a lot. It sounded generous to the public, although perhaps for scientists they weren't necessarily thinking 60 was enough, but there weren't 60. And researchers in the field were immediately shocked to hear the president say more than 60 lines. It ended up being based upon a very simple confusion between stem cell derivations and lines, which is something that a science advisor would set you straight about.
Okay, why don't you explain that, because I don't think a lot of our audience would know.
I mean, a derivation is when you crack open the embryo and you pull out some of the internal cells and you start growing them. You've derived embryonic stem cells at that point. But a lot of things can go wrong. They may not continue to grow in culture, it's a delicate process. And so, in fact, you might have 60 derivations, you don't have nearly that many lines. Lines, for scientists, meaning we've grown a colony, it's growing healthily. We can ship it to other scientists and colleagues, and we can actually start doing research on these, and that was the mistake. And it was a very significant mistake, because it turns out that the lines available are far less numerous. They're contaminated, they're genetically limited, and so there are all sorts of problems with the president's policy. And if you get the right science advice, you don't make this mistake, I think. And furthermore, there's no apology for the mistake. There's no changing the policy afterwards once this fairly crucial error is exposed.
So you're a journalist. Have you looked into the question of whether this was an honest mistake, a confusion, bad advice? I mean, do you have any idea about that?
That's tricky. It's clear that information handed off from the National Institutes of Health, which is where that 60 number came from, was misused intentionally or not intentionally. We don't know why they turned derivations to lines. Was it just an error?
I mean, it could be they thought the word derivation was too long and confusing, and lines
or maybe that's
simpler.
not what NIH used. The information handoff wasn't good. But the point is, you're the president of the United States. You have the best science advice that you want. Okay? So how does this? And this is a big speech. Don't you check it?
Yeah.
I don't know. I don't know what happened behind the scenes there. I do know that there's no apology, no attempt to, change the policy,
yeah.
So what are you supposed to think?
You've been talking a lot about the president, and one of the things that the president famously said about evolution is that he said he thought we should teach both sides of the debate.
Right.
So we're teachers here, and we have to think about this issue. And I think a lot of people find that to be a sensible proposal. I mean, why wouldn't you teach both sides of the debate?
Well, because it's not a debate within science. So if it were a debate within science, then you would probably depict it as such in science education. But if it's really a political debate that's being misconstrued as a scientific debate, which is what evolution is, the intelligent design people are clearly conservative Christians and they want to attack evolution, and they claim that they have a scientific alternative, but that's been pretty widely rejected, and they don't really have, they're not very convincing on that point. So why should we play into their way of framing the issue when they're misleading us about whether they're really doing science as opposed to doing something else? I think that you should teach both sides of the debate if you're studying it from a politics class, sociology class, perhaps religion class, history of science, exactly. I just, especially when we're talking about high schools and we're talking about very elementary biology instruction, these are kids getting it in 9th grade in a lot of cases. Okay, don't mislead the kids by telling them that there's a debate that doesn't exist within science. The kids are in that class to learn some very basic things about biology, and then the next year chemistry or however it goes. So this is not the place for introducing a pseudo-debate.
But how would you, I mean, if somebody were to say to you, well, how do you know? How do you know that this is not that these aren't legitimate? Because often the advocates of intelligent design will claim they have evidence. They have, I mean, one of the strategies they use, which you discuss in your book, is that they will find a scientist who has scientific credentials to speak to the issue. So
it's complex because people have become very good at making it look like they've got a scientific alternative. And the advocates of intelligent design are very well schooled at this. They're better than the previous creationists who didn't really convince anybody with, dinosaurs on the ark and so forth. So the intelligent design...
What, there were no dinosaurs on the ark? Sorry, I couldn't resist that one.
The ID people, what you have to do is you have to look sociologically, frankly, at what's going on within the scientific community. Are scientists actually taking intelligent design seriously as a hypothesis, and is it inspiring research? And, are intelligent design people the hot people to bring into your department, and so forth? And are there papers coming out that are presenting evidence suggesting that intelligent design is the right explanation? You start looking for that, and then the sort of cloud dissipates. And this was what the judge did in the Dover evolution trial. He said, is intelligent design science? Well, they're not acting like scientists. And sure enough, he exposed them. And this judge was a Republican himself. It's unfortunate that even as President Bush and Senator Frist and the others were saying teach intelligent design, the judicial system was doing a much better job of figuring out what was going on there.
We only have a few minutes left, so let's just spend a few minutes talking about global warming, because that's a question of huge interest to this community. As you've said, Governor Schwarzenegger has moved forward on a quite ambitious program to reduce emissions here in California. So, first of all, could you just briefly summarize what you would say is the state of scientific debate over global warming?
Well,
or scientific research, maybe is a better way of putting it.
I mean, I'm sure you've seen the detection and attribution studies where it turns out if you want to explain the temperature trends that we've seen, that if you just invoke natural causes, it doesn't match very well what we're seeing. But if you then blend together natural and human causes being greenhouse gas emissions, then sure enough, we get a pretty good explanation of the temperature trend. And that is the consensus, that, humans are causing a large part of the current spike in temperatures. Now, what percentage they're causing? Then you might get into an area of debate. How bad it will get, what the temperature increase will be in 2100. Then you get a debate. So there are certainly things that are unsettled. And hurricanes and global warming, to what extent will hurricanes be intensified by global warming? Clearly a debated topic. So there's things that are accepted and there's things that are still debated. But the basic consensus that humans are involved is pretty solid at this point.
And what about, you mentioned the issue of predicting how quickly problems will start to develop, but that's very important from a policy standpoint, right? I mean, if this is going to happen in the year 2500, we really could not worry about it for now and assume that technology will change by then. So what do we know about how rapidly these changes appear to be happening?
Right. Well, there are, of course, different schools of thought on that. But, you know, for example, James Hansen has come out and said pretty strongly that
let me interrupt for a second. Just tell the audience who James Hansen is.
James Hansen is head of the NASA Goddard Institute for Space Studies at Columbia University, but it's also a government agency, and he's the father of global warming, as they say. And he's come out pretty strong saying that the tipping point is close, that if you keep pumping the stuff in the atmosphere for that much longer without cutting it down, then we're going to start getting some irreversible changes because you start to trigger feedbacks. So ice in the Arctic used to bounce sunlight back, but if the ice is gone, then it doesn't bounce it back as much, and then heat increases, and all of these sorts of things. And suddenly, and he's really worried about catastrophic sea level rise, and that he's talking about in terms of hundreds of years for that particular problem. So some people are starting to say you need to act fairly quickly or else you're going to get irreversible changes. And that's partly because the lifetime of the greenhouse gases in the atmosphere is fairly long.
They don't go away very easily.
Yeah, they don't just disappear.
But again, just to play the devil's advocate one more time, but he's one guy.
He's one guy.
So how do you put his views into context? I mean, how do you know... Well, like I said, how do you put it into context?
Well, this is we're getting into now the complicated policy area. I mean, we're not getting into just how do we treat the science itself. We're getting into judgments about, is Kyoto the right answer? Well, Kyoto's, first of all, the time period for Kyoto is over in, I think, 2012 or 2010, I forget. So Kyoto's already almost half over. It was never that strong a policy to begin with. Maybe Kyoto is not the answer. Maybe you need something stronger than Kyoto, or maybe we're just going to try to adapt. These are political questions. I mean, and they're not strictly scientific. And I think that there are legitimate, especially considering the fact that if we're close to the tipping point and we're not doing that much yet, maybe we just have to adapt at this point because we're not going to get there in terms of mitigation. Yeah. And probably the answer is going to be some part mitigation, some part adaptation.
We need to wrap up. Is there anything else you'd like to close with, or?
No, it's been good to be here, and my take-home message is just simply that we just need to not distort the information in order to justify something that we already wanted to do in the first place. Let's just get the information right.
Yeah. Well, I think as university professors, we'd be pretty sympathetic to that argument. So thank you so much for coming. It's been a pleasure.
It's fun.
Our guest has been Chris Mooney, the author of the book, The Republican War on Science, and thank you very much for watching.